All right, are we ready? If we can make our way in and take a seat, we can get started with our next heavy hitter panel. This is going to be the state of L2s or layer 2s in 2023. And we have some pretty high level speakers here. We have Patrick McCorry from Arbitrum, Zaki Manian from Cosmos, and Arthur Breitman from Tezos. And with our moderator, Andy.
Welcome.
Oh, cool.
The state of L2s have advanced significantly in recent years, and we're here to cover current trends and key developments. And without further ado, I'm just gonna have you guys introduce yourself just briefly. What's your background and what are you currently working on? Patrick?
Oh, cool. Hi, everyone. So I currently work at the Arbitrum Foundation. My job's supposed to be leading the research and the education, but given that it's a team of 9 people, the past few months I've focused a lot on governance with the DAO and trying to understand the relationship between the foundation and the DAO. But historically I'm a researcher. I've studied layer 2 protocols for a very long time and extremely bullish on their long-term future, clearly.
My name is Zaki, long-time cosmonaut. Been working on Cosmos basically since 2014. Have a protocol called Sommelier, DeFi protocol. So I do like protocol design, DeFi stuff, that sort of thing.
Hi. And I'm Arthur Breitman. I'm a co-founder of Tezos.
Thank you. So, the state of scaling. Could you give us your take on the current state of L2 scaling? Where are we in terms of maturity, and what are the key trends we're seeing at the moment? Starting with you, Patrick.
For me, the state of scaling, I guess if you look at the rollups today, they are a magnitude cheaper and faster than something like Ethereum, for example. I'm sure for example, raise your hand if you paid more than $100 for a transaction on Ethereum. There you go, exactly. It's ridiculous, isn't it? Because of the bottlenecks. And that's just because of the architecture. It's a bit easier to scale these rollups. But it's still very early stage. I wouldn't go to a project to say, oh yeah, you can do 24,000 TPS on this, because clearly you can't. But at least it's a magnitude better, but we still need to clearly get more magnitudes out of it.
I guess though, the original Cosmos sort of viewpoint on all of this was that what we should enable is an innovation marketplace around chain designs and so in general, you've seen most ecosystems creates these marketplaces of different rollups and different vendors and people proposing different machines. Now the most successful rollups are all basically one-for-one compatible with the Ethereum layer 1 ecosystem. So there hasn't yet been that much innovation there in what a rollup can be. But it has enabled some form of cheaper transactions for a variety of different users and use cases. And we see higher transaction volumes there. And then we've also seen an explosion of just different vendors and technologies and stuff like that. And the idea that you would get zero knowledge proofs of the EVM state, it already would have seemed ridiculous 3 years ago, and so that an enormous amount of progress has been made there.
I think that the thing that ties all this together is the concept of bridging. So early on when I was working on Tezos, what's their name? The Bitcoin people. They proposed the idea of side chains. And that almost made me want to stop working on Tezos, because I was like, wait a second. If you can have a bunch of different blockchains and you can move your asset from one to the other, then you don't need so much governance on the chain itself to have innovation. You could have, like Zaki is saying, a market for innovation. You can have many different systems, and people will move their assets wherever is convenient. You might need, the only governance that you are left to have is basically around issuance, and that's it. But then, of course, they didn't have any idea how to actually build a sidechain. And I think the Cosmos model is that basically every chain is naturally bridged to the other in a light client fashion. It has a very convenient light client, and so they talk through a hub about this. And the idea of rollups, and that's what's really specific about rollup, although that's, I think, a controversial discussion now, is that rollups have secure bridging to the chain, stronger than light client. They have the same security as a chain, but they act as a bridge. And so they have this concept of innovation where you could have different design for your rollups while having the ability to move assets over. And I think for me that it's a long time solution to the scaling problem that didn't really have a good option for many years.
Yeah, maybe can I chip in there? I guess you mean the Blockstream paper, don't you?
Yeah, I was looking for the name
that was
Blockstream.
it,
Yeah.
anyway, And just for context for people here, the sidechain paper was in 2015. So it's been about 8 years now until we got to the point where like, oh, we can actually go through the theory and iterate on and actually go, oh, we know how to build this now and actually build it. So yeah, it's been a long time coming. And of course, IBC's been there as well. That's also another approach for doing it.
So it sounds like we've come a long way, but there's still some challenges facing L2 solutions. What are the main challenges at the moment? And I'm also curious, how do they differ from the challenges that the layer 1 faces?
I guess we could talk about like sort of the different challenges of the sort of layer 2 concept. The biggest concept of a layer 2 is there's no native validator set, right? This is the idea of like how you inherit the security of the base layer, is you don't have a validator set that's like producing blocks. It's its own independent sort of secure network. Instead, you are on top of the security of something else. But this implies then you need a bunch of other roles. Like you need something that proposes blocks. You need sequencing and ordering of transactions. You need people to run RPC nodes. You need to have your own independent mempool. You have to have all of this other functionality. And at least in the like sort of most dominant rollups that are there today, all of those functions today are centralized. And that represents, I think, the biggest missing link in sort of realizing the rollup vision is to have decentralized secure layer 1s. Like we figured out how to do that, and some of them do very high transaction throughputs, but we haven't figured so far we don't really have that in the layer 2 space.
Yeah, maybe another way to think of it is that I think a lot of it's a communication problem. See, when you think of a blockchain system, all we're doing is creating an off-chain database. And all I want to do is take my assets in one blockchain and move it to this off-chain system and transact there. And when people think about rollups, they sort of forget that we're just creating databases and bridges to those databases. And there's a whole spectrum for doing that. So one of the problems is that the main popular off-chain approach today is like a custodial exchange. Like FTX, for example, and obviously we've all seen what happened with FTX. It wasn't very great. But on the other spectrum of it, and that's one end of the spectrum, the other is just like a validating bridge and the most secure type of bridge. But the problem there is that then you're tied to one blockchain. So for example, the Ethereum rollups like Arbitrum, you're tied to Ethereum and it has assets on Ethereum. But you can't really bridge out to another network and get the same level of security. So there's a whole spectrum there to be sort of explored over the next couple of years, because not everyone needs an extensive, powerful validating bridge. They could have something weaker, but much better than a custodial exchange. So I think it's really working out those that spectrum and the quirks and sort of what off-chain did. I think there's going to be thousands of these systems. So I think we need to work out what will work for the most widest deployment. Maybe that's one challenge. And also is the communication around that.
I think the complexity is still one of the challenges. Whether you're implementing optimistic rollup or you're implementing ZK rollup, different type of complexity. The refutation games that happen in optimistic rollup where people can challenge things, they work, but they have a great deal of complexities that's embedded into them. And I think, to Zaki's point, part of the reason for the existing centralization today is that these are novel systems. These are big code bases. It's hard to be confident that they work correctly. And with ZK rollups, you have these enormous mathematical circuits who stand behind it. The cryptography is well understood. Well, it's relatively well understood, and it's probably not where the main thread is. But who knows if you have a bug in this giant network? So I would say that's the inherent complexity is likely a limitation today.
Yes, Arthur, you mentioned to me that we should discuss modularity because it seems to be something that's very closely aligned with the whole concept of L2s. Could you introduce the room to what is the modular thesis?
No, I was hoping to learn actually. So I'm not sure because I've seen the modular thesis, and I think it could mean two different things, right? And I think it probably means the second one. The first one would be to say it's about modular design. It's how you design your thing, and you say like the idea of scaling with rollups is fundamentally you say, I'm going to outsource execution. Execution is not going to happen on layer 1. Execution is going to be one thing. Consensus is going to be another thing. But if we do this on Tezos, it's still all essentially takes place in the same ecosystem. The other modular thesis, and that might be one that's I think like maybe Celestia is pushing in terms of like the meaning. It's saying no. This could be an entire other ecosystem. You could have different blockchain that specialize in one thing. So like maybe you have a chain that's specialized on execution, and it talks to a chain that specialize in whatchamacallit, like data availability or anything like, or you know, like in a Cosmos ecosystem where you have chains that could specialize in things and bridge to each other. So I'm not sure which it is. If it's just modular design in your code, or if it's modularity in terms of like chains and ecosystems filling different functions.
So, I guess like Mustafa, founder of one of the co-founders of Celestia, I think is probably the originator of the articulation of the modular thesis. His articulation of it is you separate out the different functions and different roles within blockchains into distinct software systems and distinct components. So data availability, which is really not something that until this like modular thesis got sort of memed into widespread adoption, very many people were thinking about, but it was very much part of the sort of blockchain discussions back in 2015. It's like Bitcoin has this really interesting property where it's like, it's kind of not that great as a consensus system, but it is a really strong system at incentivizing people to disseminate data widely. It provides really strong economic incentives for rapid data dissemination, and that provides a lot of security. So like, what could we learn from that? So there was this idea, so you know, the Celestia idea, and which is now instantiated in multiple other blockchains, Ethereum has adopted it, Tezos has adopted it, is to leverage a secure L1 for data dissemination, and then outsource like what the execution environment is, what bridging is, what transaction ordering within these execution environments to a variety of different solutions.
I'm just trying to think the best way to answer this. So I think the modular thinking was not really known until about 2018, around the Plasma era. So does anyone remember the Bitcoin block size wars? Was anyone there for that? It was a really toxic time. It was really sad because you know, the only way you could scale the network was to increase the block size, and that was it. You know, that's how you scale Bitcoin. And that's because we didn't have the right abstractions in terms of like, what does it actually mean to scale? And so you said this monolithic approach where you can just tweak this one parameter, and that's what it means to scale. And obviously people argued and fought over this. And then when Plasma came around, does anyone remember Plasma? Sorry, I'm just always like to get an idea of what people know. So Plasma popped up in 2017, and the idea was to build this off-chain database, basically like a roll-up today. But then the smart contract can verify that the off-chain database is correct and valid. And the goal there was, and the goal of all roll-ups is, given this off-chain database, how can you guarantee that everyone in this room can get a copy of it? And how can we be convinced that it's correct as well? And how do you allow a smart contract to do that as well? And so for 2 years during Plasma, because again, we didn't have the good abstractions of what it means to be modular, everyone has all these quirky designs of like the UTXO model, different transaction models, and all the designs are awful. Like they're really just awful. None of them ever got implemented or deployed. Then eventually, like Mustafa had the lazy ledger paper, people got a bit confused by it because again, they didn't understand, you know, the modular approach, but he was there with, you know, data availability. Then Barry Whitehat came up with this repo called the Rollup, where you just post the data to Ethereum. Then people eventually caught on, oh, you know, if you want to make sure everyone gets a copy of a database, then, you know, you have to guarantee they can get the data, you know, data availability. How can they verify that it's correct? Or you need an execution layer. Then the final one you could call like settlement. You know, where are the assets that you're actually going to put on this off-chain database? And I think that's sort of where the modular approach came over the years. And now we have a much better understanding of the abstractions, and it just simplifies the design when you can think about it. That's my perspective anyway. I think that's sort of how I've seen it evolve.
Just to react on Plasma, I mean, one of the things that Plasma was doing, which was remarkable, is that, you know, it actually dispensed you from the data availability. Yep. You know, and that's really that's a tricky one. But it also points at something interesting. Like it's possible to have useful systems that will work without data availability, and trying to understand where exactly are those limits. Is really, you know, I think that's a dream. Is like better than like data availability sharding. Is the idea of saying like, well, everyone who cares about a part of the state is going to be responsible for that part of the state, but not everyone needs to know the whole state. Doesn't work very well in composability for smart contracts, but the fact that it works at all for a lot of systems is really interesting.
So I have a question for you, Zaki. You call yourself a cosmonaut, and to qualify you further, you are also former director of Tendermint Labs.
Sure. Yes.
Could you? We were here to talk about L2s, but as I understand it, Cosmos calls itself a layer 0 blockchain. How are L2s different from what is happening? With how Cosmos is approaching it?
So I guess the sort of the core realization of Cosmos was, hey, we think this is the direction blockchains are going. So, you know, the sort of thesis is the app chain thesis. So what is the app chain thesis is, I think more people are familiar with general purpose layer ones and Tezos, or general purpose blockchains, and Tezos is a great example of one. They host a variety of different applications, NFTs, DeFi, et cetera. And all those applications sort of coexist within the same environment. The hypothesis that Cosmos started out with was this idea that the eventual end state of popular DeFi, popular applications on blockchains will eventually be that the application wants to control everything, like what its transactions look like, how blocks are created and ordered, what like fees and gas tokens and economics and all of that stuff. Like eventual end state is customization. So if you wanted that, and this was before scalable data availability was invented, it was before fraud proofs and validated bridges. Like there was this concept of what we call one-shot fraud proofs, where you would like basically post like a proof of all of the data that was needed and the transaction, and you would show, which, you know, to this date no one has really ever deployed. And so, you know, all of this stuff was very immature, but what we had was a consensus algorithm that had really that was really good at building light clients that were extremely cheap in the sort of normal case and could be expensive in like the worst case. Let's say the validator set was changing dramatically every block, but that doesn't actually happen very often in real life. So you instead we had this like very efficient system. And so what we wanted to do was use that as the first iteration of a system that enabled this app chain thesis. And then we have like sort of 50 app chains on top of Cosmos today. Actually, probably more now. 50 is probably an old number. A bunch launch, new ones launch every couple of weeks. And we seem to be back into that phase of them launching all the time. So that all worked. I mean, and unlike a lot of these systems, during the DeFi panel, there was a lot of talk about Terra. And Terra was a Cosmos chain. And it was connected to the IBC network. And many of these systems have never yet been subjected to a massive financial calamity of, $60 billion vanishing before your eyes. On one hand, it's like that was tragic and terrible. On the other hand, the system did work. It was insane seeing like multi-billion-dollar arbitrages happening over IBC. But it like happened, and it was wild.
Arthur, you expressed a little bit of skepticism earlier about app chains as a future. Could you comment on?
And so I think a lot of people looking at rollups have in mind the app chain model, and I think for some application it does make sense to have like this level of control over the application, but I think it goes into there's a tension between two things. Like on one is the desire of controlling exactly your gas costs. Like you don't want to share the chain with someone else because that someone else might have a bunch of transactions and all of a sudden your fee spikes. But I think that's from a world where transactions are limited, and in a world where transactions are abundant, people care a lot less about that. Customization, again, I think that comes down to how easy it is to deploy. If you're writing a contract in a quirky smart contract language, maybe you want to say like, no, I just want to use a regular language, and you build your own chain like this. But if you can use those regular languages for building smart contracts, you don't have this limitation. So once you can really customize your smart contracts, not have to worry about competing for block space with other people, then at that point you'd rather say like, oh well, I'd rather have this very like tight composability with other contracts. So I think we'll move more towards that given the technologies that's available today.
So we're in the midst of a very interesting test case in the sort of Ethereum Cosmos ecosystem right now, where there's an application called DYDX. And DYDX has been an L2, that L2 does like roughly $1 billion every day of trading volume in the bear market. Like, it's crazy. So like one of the most successful, most valuable use cases, it uses Starkware's platform today. And mostly what they've wanted to be able to do is get extreme customization on essentially like block production on consensus, and like pre-consensus and consensus activity in that process. And so they've spent the last year building a Cosmos app chain that will replace their current L2 solution. And it is the most advanced Cosmos chain that has ever been built so far. And it is going to be very exciting to see how that goes. And it's going to be an interesting sort of study in the trade-offs. And it's not like it's not like there's a theoretical engineering reason why DYDX couldn't build what they were trying to build as an L2. It was more that like the available set of L2 tools were not mature enough for their use case, whereas the Cosmos ecosystem was like plausibly mature enough for them to achieve their targets in terms of performance and decentralization. But it's yet to be seen like whether or not this works.
Well, can I add a comment about the op chain thesis?
Absolutely.
So whenever I hear people talk about the op chain, it always feels like it's far distant idea that people are eventually going to build and there's going to be use cases there. I just get a little frustrated because if you look at the ecosystem today, if you consider everything as just a database, there's hundreds and thousands of databases out there that are fully custodial, fully private, and they could really just benefit from this stack. Like, like Coinbase is doing Base now. I used to say that rollups could give you a Coinbase-like experience, and now they're actually building on top of a rollup. And so I feel like the databases are there, like the operators are there. They just need a better technology stack so they can just deploy it, and then I don't have to trust them with my funds. And long term, that will allow, because right now in these systems, the operators are all powerful and they can abuse their position. And with this new technology stack, you reduce the power of the operator to be the same as the user. And by building that, you reduce the friction where they can actually transact, and I no longer have to trust you when I lock funds into your system. So all the databases are there already. Like, we don't need future apps. We just need the technology stack to be mature enough. To Zaki's point, it needs to be mature enough for people to just adopt this and not use SQLite or whatever the stack they use now. So I'm not a Web 2 guy.
And that touches on a question I have for you, Patrick, as the one representing the most pure L2 here. What factors are contributing to the adoption or lack of adoption of an L2? And how do you see it changing over time?
The adoption. So Arbitrum's been quite lucky. Arbitrum has a growing and healthy DeFi ecosystem. And my understanding for that is, so far, Arbitrum's done very well and never the pick favorites when it comes to DeFi. So if you consider the Arbitrum launch, they had this gated period where any company could come along, deploy their smart contracts, and then all the users came at once. And there's never been an opportunity where you could say, this was handpicked by Arbitrum to be the best DeFi protocol. And so they've been trying their best to be credibly neutral. And by doing that, you sort of foster this environment where people feel like they can come and be an eco partner. I think so far that's been a big chunk of their success. And the other part maybe is also, like the Arbitrum team, like the founders, et cetera, like the Off-Chain Labs team specifically, they're all like academics. So my fear initially was that they just write papers. But no, when academics do something, they do it right. They just keep iterating, building the technology, slowly making these releases. And people are like, damn, look at this, they're actually going for it. It's there. The owl is being drawn. We can see the owl's eyes. Maybe it's missing the feet, but the eyes are there. So I think that's so far been behind the success of Arbitrum, at least.
It is one of the funniest outcomes in all of this that Stephen Goldfeder, who spent 5 years in a cryptography monastery writing MPC ECDSA papers, is now the biz dev guy for Arbitrum.
The funniest outcome's always the best outcome, isn't it? Gotta respect it.
Yeah, an interesting possibility that for the DeFi success of Arbitrum, but also when you explain the DYDX choice of going on Cosmos, is that I think a lot of these trading protocols, once they become fairly large, the main thing that becomes a limitation is MEV and ordering of transaction. And so what they get on Arbitrum is a sequencer who the determinism, you go to the sequencer, you know exactly what state you're executing again and what state you're going to get after that, without being sandwiched, and hopefully the Arbitrum sequencer doesn't go and like sandwich your transaction. And same for DYDX. It's like that's why they want this type of control, because if you build a DEX in an institution where anyone could submit something, then you have a little bit of these games happening.
Let's talk decentralization, because that's why we're here after all.
Wait, they're supposed to be decentralized?
I heard so. Yeah. How do layer 2 solutions impact the decentralization principle that's so key in blockchain? Like, are there some trade-offs that we should discuss? Governance might be one aspect. Start with you, Patrick. Like Arbitrum is working on the government aspect at the moment.
I think, so this sort of just applies for rollups in general, this comment. So basically, if you have a secure layer 1 platform, you know, it could be like, you know, Ethereum, it could be Cosmos, Tezos, whatever. Like normally for a layer 1, at least in our world, the goal of decentralization is between who's running the system, who you can check that is correct, and of course how affordable it is as well. You have this sort of triangle. And typically for these layer 1s, we try to maximize the set of validators. So you can see in Ethereum, you know, at the protocol level, they have 500,000 validators. In reality, you know, people run multiple validators and we don't know the true number. But the goal is to maximize who can participate in protecting the system and helping it operate. So when it comes to rollups, there's no point recreating the wheel. You know, this already exists. It's like you can just leverage this ecosystem, this consensus protocol that's already did its best to maximize what we think is decentralization to that community. And so in a rollup, what you really want to prioritize is access. You don't need 10,000 validators per se, or at least, you know, depending on how you approach it. You just need a few validators who can, well, you need it to be open so that anyone in this room could step up, do the right thing, and save the day. So that's also why it's quite tricky when it comes, I mean, and just to highlight this, there's also two parts to what it means to be secure for a rollup. There's the day-to-day operation, the protocol itself, you know, how does the sequencer work, how does the validator work, are they using fraud proofs, validity proofs, and then there's the governance backstop. You know, when this breaks down or if it needs upgraded, you know, who makes the decision on how to change the software? And obviously for like a DAO, where if you have direct governance, you know, even Tezos has like an on-chain DAO. I think the first governance vote was in 2019, if I remember right. You know, they've been doing it for a long time. Oh, it's just for Tezos, the Baker vote.
The bigger, yeah.
So like, you know, this direct on-chain, you know, governance and voting, there you really want to just maximize who can participate as well and make sure everyone's voice is heard and try to make it as, hopefully as equal, or at least where the people who have the skin in the game can vote the most. And that's very tricky, the governance part. You know, I think that's one thing a lot of people are still missing, is to fully understand that. So that's my perspective anyway. Sorry, do you guys want to jump in?
I guess speaking of governance, I think one of the things that we are starting to see now is that in governance, in a lot of these systems, the bridge gets a vote in governance. And that becomes like a very important example of like, what is an L2 system? What are bridges in general? So like, you could have a blockchain like Phantom, which, you know, is notionally secure and like it's consensus system and notionally decentralized. But if all the assets run through a bridge that is running on a single cloud computing account that can be seized by the Chinese police, your security model is effectively the model of your bridge. But when you introduce roll-up bridges, the other thing is the bridge gets a vote because it can actually allow essentially everyone to withdraw their funds without the permission of the system that you're connected to. So whoever's running, you know, the sequencer, et cetera, of a roll-up, one of the authorities the bridge has is it could say everybody gets their funds out, no one else, like you don't have control, and they can enforce conditions like your state machine must obey some rules, you need to submit some zero knowledge proofs according to this circuit, like your systems have to be, like it actually gets a lot of control. And so one of the things that we've spent a lot of time with layer 1 governance and Cosmos and Tezos, et cetera, and those things have incredible power. One of the things that L2s introduce is this ability for the bridge to have a vote, and one of the things that's interesting about Arbitrum and the Arbitrum DAO is the DAO actually owns the bridge now.
So I challenge that we're here for decentralization. We're here for censorship resistance and
Settlement assurance.
Security, settlement assurance, resiliency. Now, unfortunately, we don't know how to do this without decentralization. Like we need some decentralization, ideally as little as possible. Why? Because it's hard to guarantee decentralization. But in some cases, we can use math instead of decentralization, and that's way better. So we need to have some decentralization, and I think if you really, really push it, the last thing you really need decentralization for is consensus and like ordering, and almost everything else you can do without decentralization. And that's the point of like optimistic rollups, where you have a single honest validator assumption as opposed to a majority assumption. A majority assumption, you want lots of decentralization. A single honest person, you're like, well, as long as there's one person who cares, this will work out. So that's much better assumption in general. And as long as we can have assumptions like this, we should push them. I would say that probably the biggest hurdle for decentralization of rollups today is, I think I mentioned it, is security and implementation risk. Is a big one, and probably the reason why there's some centralization. The other one I think is, I was touching on it earlier, is you get a lot of efficiency from having sequencers. There's a lot of benefits from having sequencers, but it can also reintroduce some form of centralization. Even if you have a token or something like that, then you're back into this kind of like permission without being permissioned type of system. So those are, that's where I think you see trade-offs. For example, like if DYDX completely controls the mempool to avoid MEV, that implies some level of centralization, but they get a benefit from it.
Oh, can I jump in quickly? I just want to get to the point of the bridge. So I think this is really important. So for the past few years, I've always been talking about bridges for layer 2s, and I think most people, I don't want to say they got angry at me, but they've maybe misinterpreted how I think about this. So when you think of a rollup, again, you have this off-chain database, and everyone in this room can validate that database in real time, and everyone can check that's correct. And a lot of these rollups, so that's like the database. You can even just call that the rollup, in the sense that everyone here can get access to that data and recompute the database. And at the heart of these rollups is this validating bridge that holds the assets. And so if there's a bridge that holds like 90% of the assets, then it becomes like this tug of war between the community who's validating the database and the bridge that holds all the assets to the database. And obviously, as a smart contract, it's very difficult to change. So if you want to update the rules on what this database means, you have to convince the bridge that you have to upgrade the state machine or the state transition function in order to process and upgrade for the network. But long term, what we're also going to have is, so right now, these bridges do have most of the collateral, but long term, there's going to be multiple bridges to the same system. And I think what we may end up with is like a battle of the bridges, where maybe you'll have Tether fight off against, I don't know, one of these validating bridges for a rollup. And it'd be quite interesting there to see the dynamic. But yeah, so the bridge, so in Arbitrum's case, they control the bridge to the network. And obviously the bridge has most of the assets, and that's where it gets a sort of authority and power over the ecosystem. So I just wanted to clarify that. You have the database, then you have these bridges, and someday we have multiple bridges of varying degrees.
Oh, before we go to the questions from the audience, just one brief, very brief question. The future outlook, where do you see layer 2 scaling solutions going? What upcoming technologies or trends should we be aware of?
I guess, so in general, the layer 2 ecosystem seems to have enormous amounts of momentum behind it, it seems like. And there are all these usability questions, but there seems to be an enormous amount of actually energy and research and progress now behind sort of this ideas like the intent-centric architecture and all of these new ways of making usability and bridges much more viable for users. So it seems like we sort of have found our map as a community. There's only maybe 3 blockchains that have at least high market caps, Aptos, Sui, and Solana, that are not really doing rollups in any shape or form. Every other ecosystem is doing rollups. And another interesting thing is now you're seeing more and more infrastructure ends up being shared between ecosystems. So we can share zero knowledge circuits between ecosystems. We can share code bases between ecosystems. A rollup on Celestia and a rollup on Ethereum can be almost identical. Sequencers are talking about providing sequencing across multiple DA layers. We have 5 different DA layers. All of these things. So there does seem to be this homogenization in general of blockchains that's happening, and I think that's probably good for users because users don't really care about the blockchains. Like we have our like sports teams and like we love our various tokens, but like at the end of the day, like if we're gonna have 1 billion users, they're probably not gonna care about this stuff. They're just gonna want to like play their hamster race. If you've been following the hamster race meme last night, you know this is what blockchains were for. So you know they don't. The hamster race people, I don't think really care. And so that is what I think is the outlook of L2s is actually just like homogenization of blockchains into like things that end up starting to all be very similar to each other.
Yeah. Arthur?
I'll repeat what I said this morning is L2 basically as, I think we'll see more L2 as vertical scaling solutions as opposed to being horizontal scaling solutions. So beefy L2s.
I mean, I've got sort of two answers to this in a way. So back in 2018, I was at a conference and I was on a panel, and I made a joke during it and everyone laughed, but I was deadly serious about it. And I'll repeat, I mean, it's not even that funny. I don't know why they laughed. But my long-term vision has always been, I want to be able to visit a website that's written in Chinese, because obviously I don't speak Chinese, so for me it's just like I can't understand what the website is. It's a horse racing game. I want to be able to lock my funds into the system, play the horse racing game, and be convinced that they're not cheating me in the horse racing game, and then I can just withdraw my funds. Like that's it. That's all I really care about. And so when I measured the success of these roll-ups, and see, it's not even funny, is it? No one laughed. Don't get why they laughed last time at it. Probably thought I was ridiculous. But so normally when I
Hamster racing.
or hamster racing, there you go, hamster racing, exactly.
Horse racing is so 2 days ago.
Exactly. This is 2023 now, isn't it? All about hamsters. But normally, like, that's always been my sort of guiding principle of the type of system I want to see. And so when I see these roll-ups emerge and sort of how they're building it and you know how they iterate towards this goal, that's what I get excited about. I'm like, okay, eventually I'll be able to do this hamster racing game and I won't have to trust the operator anymore. So it's always been my guiding principle in terms of what I want to see achieved and trying to find the right tools for achieving that goal. Then the second part is about the tools itself, and you sort of alluded to this already. You know, you have like the SUIs, the Solanas, you have the Ethereums, the Tezos, the Cosmos. I mean, they're all this map of sort of different ways, sort of to try to solve the same problem. And I really like the fact that you have this open marketplace of all these different approaches, and eventually it's going to be the market and the users who decide this is the right approach for what we want to do. And hopefully they care enough to make the right approach. You know, hopefully we don't end up on the Facebook of roll-ups. But the thing is, I'm happy there is this marketplace where people can get funding, they can experiment, we can challenge each other with different technical ways to solve this problem. So that's sort of how I try to answer that question, at least.
Thank you. Let's see if we can sneak in a few questions from the audience, if any.
Yeah, I think nice to hear that you're focusing on the UX part of it as well. I think I sort of compared a lot of roll-up discussions and stuff like that to friends discussing whiskey, which is very much like people enjoying all of the different specialties, the different flavors of it. So I'm curious if the current users are actually the ones to sort of track in terms of are they actually playing the hamster game the way we would like them to play it, or are they too much enjoying all of these different flavors of roll-ups, tokens, that kind of stuff?
I mean, maybe I could take a tackle at that first. So my worry so obviously in the community we care about the special features, and the thing we should try to avoid is to make sure those special features don't bubble up to the user level. But they always do, they always impact the transaction fee or maybe how they can interact. But I do know, like, normies, like non-crypto people, like one of my friends was on So Rare banned football players. He likes playing fantasy football. And he went on, he used his credit card to get some of the tokens, and then he started banning these fantasy football players. And I was really excited by that. That normies, it did work for him. He really enjoyed it. So yeah, I think people do use it. So maybe someone else wants to tackle that in terms of the user experience.
I build a end user DeFi app, and I have, like, the increasing complexity of how all these systems and bridges and everything really, and how much of that is smashed into the user's face, has been like a really hard problem for us to solve. But I think a lot of like what is happening in the sort of discussion has been now maybe the last 5 years have always been like, can we make it secure? Can we make it decentralized? Can we invent this like incredibly ambitious cryptography system? Like, it's a lot of enabling technologies, but like as you deploy those enabling technologies, the experience of user friction has only gone up. I would say if you sort of track, like discussions over the last week and discussions over this year, I think a lot of ways what the research communities are now working on is more and more focused on, okay, like we have the basic infrastructure and like basic design of a secure, reasonably scalable, reasonably affordable system that can support many use cases. Now, how do we like fuse that with stuff that is like actually usability oriented? And so I think the usability stuff is coming in the next year or two. It's actually coming way faster. Like I thought, like I was very surprised to see Uniswap X launch and for them to like talk about doing a cross-chain swap thing at like the highest order flow front end. So I think these things are actually moving more fast than we thought.
I think we're still in an industry where there's like far more infrastructure being built than demand for the infrastructure, and so it's an industry that attracted a lot of thinkers and builders who like to build the systems because it's interesting and it's puzzle driven. The use cases, like some of the most fundamental use cases that the system is supposed to cover were covered early on. And I think a lot of people said like, oh, what's next? I remember, even like 2014, people saying like, money is just the first app. It is the most important app. And for a lot of things which, if you're trying to build, like the systems are built for like, I'm in a war zone and, my assets might be seized. What can I have? Or I need to make a really secure private transaction across borders. Like, these are use cases where you're going to tolerate really bad UX. Now we want to have wider use cases for like much larger audiences. And yeah, as soon as you get there, then the UX demand become much more important, and it's a shift in culture. And I think that takes a while.
We have time for one more question, and I saw a hand over here. Yes.
So I wonder about your opinion on shared sequencer stuff. So is it like actually a solution, like what, like Espresso doing like Astria, or it's like another bottleneck?
I don't think that there's widespread consensus yet on what shared sequencing means. Is probably, and like what Espresso is building and what Astria is building are like flavors of that. So like the idea of a shared sequencer is, okay, so like most popular blockchains, L2s right now have a single centralized sequencer. We don't want to recreate L1 consensus, so you don't want to like run Tendermint or something like that to like have multiple sequencers. So now like what would be a good alternative? And so what you have these, you have Astria and Espresso building systems where it's like, okay, you'll have a thing that produces a block, but it doesn't produce a state root, i.e. it doesn't compute the state transition, it just orders some sequence of transactions. But it could do that as a service for many rollups, giving them stronger liveness properties, but as a shared resource. And because the bridges are validating, you don't have as much pressure for like the block producer to be like essentially executing all of the transactions and doing correctness. So this is an interesting design direction, but I don't know that it's like the last word in anything.
Maybe if I step in, normally when I hear shared sequencing, just to the definition part, I always ask them to clarify it first, because it means different things to different people. And one could be like, having a big decentralized, like using like eigenlayer, for example, we're using all the validators there, or it could just be one company like Astria that's going to support multiple rollups. So the way I like to think about it is that when you think of the rollup architecture, if you think of the fraud proofs and the provers and the ZK proofs, etc., or validity proofs, that's the back end of the system. You shouldn't really have to care about the back end, ideally, if you're going to deploy this as a technology stack. The only thing you care about is the sequencer, because the sequencer's job is to take the user's transactions, order them, and then pass them on. Either they pass it to the bridge or they pass it on to the executors. And so when you say shared sequencing, to me it's sort of controlling the user experience, like who's going to order those transactions. And that's like the front end of the system. So to me, it's a bit like, maybe it's like WordPress. WordPress takes all the ordering job for me, and I just to put up the content, and they take care of the sequencing. Or maybe if I'm someone like Coinbase, and I want to control that user experience, I want to decide the ordering policy. So to me, it's more like a front-end issue. Do you want to deal with the ordering, or do you want to just outsource it to someone else?
The main thing I've seen around shared sequencer is the prospect of having atomic transactions happening on several L2s at once. And that I'm a little bit skeptical. So one model might be like, oh, I'm a user and I want to do a transaction on this rollup, but only if a transaction on that other rollup happens. And so I'll submit both transactions as a batch to the shared sequencer, and then they will be sequenced on both rollups at the same time. And if that's what you want to do, that can work. But generally speaking, a lot of people present that as, oh, you could do swaps between rollups this way. And it's a bit more complicated than that. So normally with a sequencer, even if you have a single centralized sequencer, you do not trust the sequencer for safety. Like the sequencer cannot steal money from you. They can censor you, or they could just like not include your transaction. But if you design the system, well enough, you could say, well, the sequencer may be forced. You can have another source of transaction and like delay them. I think Arbitrum did that. So, the worst a sequencer can do is like throttle the system, make the system slow if they decide to stop working. But you don't trust them with that much, which is a good thing to have. Now, if you want to start doing swaps, with a sequencer, the problem is you could have a shared sequencer. You submit a transaction, it gets sent to two rollups, but you don't know if it's going to succeed on both. And then you read it and you say, oh, but don't worry, the sequencer will verify that it happens. And then you say, well, what happens if the sequencer lies? Oh, then you can slash him. And okay, well, now what you've built is like you've built a centralized bridge where you can slash the bridge for misbehaving. You're not really bringing anything new. So I don't think there's a whole lot of benefit from the atomic execution that a share sequencer is. I can't speak to the UX. Maybe it's like so convenient for people to submit always the same IP address, whatever transaction they want for different things. But in terms of like how much cross rollup it buys you, I don't think all that much.
In fact, Dan Robinson, I don't know if you're going to mention it, Dan Robinson had a Twitter thread about that in a poll.
Yeah.
Like, what can share sequencing guarantee? Does it guarantee atomic execution or just inclusion? And obviously it isn't atomic execution. But most people voted for that because there's just misconception.
Yeah, I mean, I think like there are interesting designs for atomic execution, and there are interesting things you can do if you have zero knowledge proofs of correctness. Just which is another further down the rabbit hole. But I would basically say all that exists today, right now, from a shared sequencing point of view, is exactly what Arthur was talking about. Like some sort of common system that can like take transactions, route to multiple systems, and that users don't have to deal with, hey, like, oh, here are all these different RPC endpoints and everything. And that architecture could be simplified in a way that like has some level of decentralization and sort of, so like, I guess there's shared sequencing, there's decentralized shared sequencing, and then there's shared validity sequencing, which is probably like, let's say 3 categories. I don't know if these are the official nomenclature yet, but so like mostly you're seeing shared and decentralized shared sequencing as systems that people are actually building, and mostly people are just writing like HackMD documents about shared validity sequencing. There's some good HackMD documents about shared validity sequencing though. So. Yeah.
Okay, I think we need to wrap it up. Thank you so much for your perspectives on this, and give them a big round of applause.